In this video, we'll be going over section 2.2, which is over sampling. Now, many studies are conducted in order to generalize from a sample to the corresponding population. As a result, it's important that the sample be representative of the population. So, to be reasonably sure of this, we must carefully consider the way in which a sample is selected. It is sometimes tempting to take the easy way out and gather data in like a haphazard way. But if a sample is chosen on the basis of convenience alone, it becomes impossible to interpret the resulting data with any confidence. For example, it might be easy to use all the students in your statistics class as a sample of students at, let's say, your university. However, not all majors include a statistics course in their curriculum, and most students take statistics in their sophomore or junior year. The difficulty is that it is not clear whether or how these factors, and others that we might not be aware of, affect any conclusions based on information from such a sample. Now, there's no way to tell just by looking at a sample whether it is representative of the population from which it was drawn. Our only assurance comes from the method used to select the sample. So we're going to begin by talking about census versus sample. So a census is when we are obtaining information about the entire population. Well, why might we prefer to select a sample rather than performing a census? Well, one reason is that the measurements that are required might destroy the item, like measuring how long a battery lasts or the safety ratings of a car. We wouldn't want to use every single car for that, or every single battery. There would be none left. Another reason is that it's difficult to find the entire population. For example, if you were trying to find the length of fish in a lake, you could have a hard time with that. And another reason is limited resources. It takes time and money in order to complete a census. And really, this is the most common reason to use a sample. So let's talk about some methods of selecting random samples. So a simple random sample, otherwise known as an SRS, is a sample of size n is selected from the population in a way that ensures that every different possible sample of the desired size has the same chance of being selected. So suppose a local school has 2,000 students, and we want to survey 100 students about the current cell phone policy. A sample of students can be selected by putting each student's name on individual but identical slips of paper and placing them in a large container. After mixing well, randomly selecting 100 names from the container, one at a time. So it has to be possible for all 100 students in the sample to be seniors or any other combination of students. A simple random sample does not guarantee that the sample is representative of the population. Let me say that again. A simple random sample does not guarantee that the sample is representative of the population. Now, another way to select a simple random sample is to create a list of all of the students in the school. We call this a sampling frame. Okay. Now, a sampling frame is just a list of all the objects or the individuals in the population. Okay. So we would number each student with a unique number, so from 1 to 2,000. And we'd use a random digit table or a random number generator. So a calculator or computer software program will do this to select the 100 students for the sample. So there's a couple different forms. So one is a random digit table, and this is in the back of our book on page 860. Now, this is part of the random digit table found in the back of our textbook. Since our students are numbered from 1 to 2,000, we will select 4-digit numbers from the table. If the number is not within 1 to 2000, then we will ignore it. Now, in order for it to be random, you must choose the same size group of numbers throughout the table. So from 1 to 2000, the greatest number has 4 digits because 2000 has 4 digits. So the group size is 4. So here we would have person 938 or 7,679, which that number is bigger than 2000, so we would ignore it, right? We move on to the next number, 9,562. Again, it's bigger than 2000, and so we would ignore it. We move on to the next piece, 5,658. Again, it's bigger than 2000, and so we would ignore it. And we just keep moving on as we go through until we find other numbers that will match. For example, here we have person 220. That person will work. And so as we go through, we just look for numbers where people exist in our numbers from 1 to 2000. So as you can see, sometimes you have to cross out a lot of numbers to be able to get numbers that you can use when using a random digit table. But we still end up getting our numbers. So we would continue in this fashion until we had selected 100 numbers. So right here we did all of that work and we have 6 numbers. So it would be way faster to use a random number generator. Random numbers on calculators and Excel. This is how to do it. So here we have the directions for how to use a TI-83 or 84 and the buttons you need to push. We have the directions for a TI Inspire. And it's important, okay, you must enter a starting number and an ending number and then how many random numbers to generate in that order. So your starting number, your ending number, and how many random numbers. So for us, we would say starting at 1, going to 2000, and we're picking 100 numbers. So let's keep talking about simple random samples. Most often, sampling is done without replacement. So that is, once an individual or an object has been selected, they are not replaced and cannot be selected again. Now, sampling with replacement allows an object or an individual to be selected more than once for the sample. Now, although sampling with and without replacement are different, they can be treated as the same when the sample size n is relatively small compared to the population size, meaning no more than 10% of the population. All right, so let's talk about some methods of selecting random samples. So here we have stratified random sample. Now, the population here is divided into non-overlapping subgroups called strata. Simple random samples are then selected from each stratum. Strata are groups that are similar, so they're homogeneous, based upon some characteristic of the group of numbers. Instead of a simple random sample to answer our survey about the cell phone policy at school, suppose we were to take 4 simple random sample sizes of 25 from each grade level: freshmen, sophomores, juniors, and seniors. This method is easier to implement and is more cost-effective than simple random sampling. It also allows more accurate inferences about the population than a simple random sampling. Let's talk about another method. Another method is a cluster sampling. So here, the population is divided into non-overlapping subgroups called clusters. You randomly select clusters, and then all the individuals in the clusters are included in the sample. Now, to answer our survey on the current cell phone policy at our school, we would randomly select 5 classrooms during second period. We would survey all of the students in those rooms. So what are the clusters in this example? It would be the classrooms. Cluster sampling is often easier to perform and more cost-effective. Clusters are often based on location. It is best if the clusters are heterogeneous, subgroups from the population. Now, heterogeneous means diverse, okay? Diverse groups from the population. Let's talk about systematic sampling. So systematic sampling is another method of selecting random samples. Here we have a value k is specified. For example, let's say k equals 50 or k equals 200, right? One of the first k individuals is selected at random. Then every kth individual in the sequence is included in the sample. So suppose we randomly select a number between 1 and 20 using an alphabetical list of students at our school. Select the students whose name is at that number in the list. Then choose every 20th student from there. So you're basically looking at every 20th student on the alphabetical list of all the students at school. Now this method works reasonably well as long as there are no repeating patterns in the population list. Let's practice identifying the sample design. So in our first example here, the Educational Testing Service, or the ETS, needed a sample of colleges. ETS first divided all colleges into groups of similar types: small public, small private, medium public, medium private, large public, and large private. Then they randomly selected 3 colleges from each group. What type of sampling design was used here? Push pause, make a decision, and then go ahead and push play and let's see if you were right. Our answer is that it's a stratified random sample. We know that it's a stratified random sample because the entire population was able to be divided into the set of non-overlapping subgroups. Then, separate simple random samples were independently selected from each of those subgroups. Let's take a look at our next example. So our second example here, we have a county commissioner wants to survey people in her district to determine their opinions on a particular law that's up for adoption. She decides to randomly select blocks in her district and then survey all who lived on those blocks. So I want you to go ahead and push pause, and I want you to decide which sampling design was this. Then when you're done, push play and let's see if you were right. Here we have an example of cluster sampling. We know that it's cluster sampling because the individuals were divided into the population into non-overlapping groups, right? And this was like the blocks. And then these clusters or these blocks were selected at random, and then everyone who lived on the block was then surveyed. Let's look at our third example. Here we have a local restaurant manager wants to survey customers about the service they receive. Each night, the manager randomly chooses a number between 1 and 10. He then gives a survey to that customer and to every 10th customer after them to fill it out before they leave. So go ahead and I want you to decide what sampling design this is. Push pause, make the decision. When you're done, push play and let's see if you were right. So this is an example of a systematic sampling, because here we had a K value, looks like 10, so that every 10th person was given the survey to fill out.